Hey, welcome to Unit 1, Lesson 2. This is going to be all about arithmetic sequences. And if you watch that little intro video before this, you hopefully remember that arithmetic sequences were adding a constant number or subtracting if you think about adding a negative. So just want to do a little quick warm-up here, just kind of noticing some patterns. Just taking a look here, how are the figures changing? Okay, so I look here and I see there's one dot here in this one, right? And I'm actually going to go maybe below it here. So there's one dot there, there's three dots here, there's five. Wow, can't count. How about six? There's six there, there's 10 here. So it doesn't look like there's like a consistent change, right? You know, this one here going from 1 to 3, you're adding on 2. From here, you're adding on 3. Here, you're adding on see, like, and just stuff like that will help you out. So you notice that it's adding 2, adding 3, adding 4. So this next one would be adding 5, right? So there'd be 15 dots in that fifth figure, okay? So maybe you notice here too, like this one dot is all the same here. And then you got these 2 dots here going across. So it keeps on like adding on a row to the bottom, right? So here you'd have 5 dots on bottom, and then that whole picture to the left would just be stacked on top, okay? Yeah, you know, it looks beautiful, huh? So now it's saying how many dots in the 12th figure? A couple ways you can think about it. You can kind of just count on your hands, kind of go up that way. I like making a table. So here's, I'm going to go the first figure, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11th figure, and the 12th figure. So we're trying to figure out this one right here, okay? How many dots are going to be in that figure? Well, I mean, like, okay, there's 1 dot in this one, and then 3, and then 6, 10, 15. Okay, so this one was adding on 5 there. So now I'm going to add on 6. 15 plus 6 is 21. And then what are you going to add on? 7, right? 28. And then I'm going to add on 8. That'd be 36. I'm going to add 9, 45. Then I'm going to add 10, 55. Add 11, 66. And then add 12, 78. There'd be 78 dots in that 12th figure. Okay, so technically this little example here is not an arithmetic sequence because it's not adding the same number over and over again, right? It's changing that way. It's still a pattern. Still a sequence, is just not an arithmetic sequence, okay? So today, or in this video, we are going to talk about arithmetic sequences. Holy cow, okay, let me see. There we go. Okay, so just going to go through a little example. Here, this is an arithmetic sequence. It says describe how the numbers are changing. Now look at this notation here, this A with a little 1 underneath it. I'm going to call that A sub 1. Okay, so A sub 1 equals 2. All that means is the first term. Okay, that's all that means. The first term is 2, so that means the second term is 5, third, fourth, fifth, sixth, right? So describe how the numbers are changing. Well, from 2 to 5, that's adding 3, yeah, and now at this point, it's like, okay, well, we're doing arithmetic sequences, so it should constantly add by 3, and it does, okay? So how the numbers are changing, you could do like plus 3, right? If you show this little plus 3 on the bottom, that's fine, okay? So I know it's adding 3 each time. Now it says use a table to help graph this sequence. So I got the first term is 2, the second term is 5, the third term is 8, the fourth is 11, the fifth is 14, and the sixth is 17. Okay, so what I'm going to do is I'm going to graph these as like an XY coordinate pair. Okay, so 1, 2, X coordinate, Y coordinate. So I go 1 on the X-axis and then up 2. Right there, there's 1, 2. That's the first term. 2, 5. I'm sorry, that's not 5. How about this? 1, 2, 3, 4, 5, right up there. 2, 5. Sorry, it's kind of hard to see on the side there. 3, 8. Right up here. Okay. And now I'm going to kind of get stuck here. You do 4 comma 11. It's like up here, right? So you can kind of see that. Think about what does that look like? To me, it looks like a straight line, right? Do y'all remember for something that's a straight line, you remember y equals mx plus b, right? So that's going to help us kind of determine some things later on, like writing an equation and all that, okay? So let's talk about this y equals mx plus b. I mean, this plus 3 that we're doing here, you see that plus 3 right there. That plus 3 right there. Okay, that's that going up by 3, right? So that, if y'all remember what that m stands for, that's your slope. Okay, that's the slope of your line. Do y'all remember what the b stood for? What that b represents? That's your y-intercept. Okay, or that's where it crosses the y-axis. All right, so be careful. It's not 2, okay? It doesn't cross right here at 2. So I'm going to go back down to this question right here. What is the number that comes before the first term? Okay, so let's think about this. I'm going to look at, and we're focusing on this y-intercept, okay? So here, going from 2 to 5, we're adding 3, right? 5 to 8, we add 3. 8 to 11, we add 3. So what would I do if I went backwards? If I'm adding 3 going to the right, I'm going to subtract 3 going to the left. 2 minus 3 is -1. Right? So over on the graph here, let me pull out my laser pointer. And guess what? I'm going Luke Skywalker action here. So here, we're adding 3 going up, right? That's our slope. So if I go down, I'm going to go down 3. 1, 2, 3. I'm at -1, right, off the graph. And then back 1. There's that y-intercept right down here at -1. Okay, so the number that comes before the first term, I'm going to say is -1. That's our y-intercept. So let's put this all together. Write an equation for the sequence. Well, we know we can do y equals mx plus b. It's a line. Those are linear equations. Okay, so I can do y equals, the m is the slope, and remember that slope is up here. That's how it's changing. So it would be 3x, and then the y-intercept is -1. There's that equation for the sequence. Okay. I'm going to say this, and I'm probably going to try and say it over and over again. An arithmetic sequence is a linear equation. Okay? And I'll say that over and over again, hopefully. Hopefully I remember that. Now it says, what's the 10th term? Got a couple options here. We could just keep on going here. The 7th term, if you keep on adding on to the table, the 7th term, remember we're adding 3, would be 20. Okay, you could keep on doing that. 8th term, 23. 9th term, 26. 10th term, 29. Okay, so I kind of did that in my head. I counted, maybe I was using my fingers, actually. That's totally fine. Continue that table. Move on, right? If I said, what's the 100th term, you probably wouldn't want to do that. That's where we can use this equation. Okay? So we said we got 29 using that table. The 10th term, let's plug in 10 for x. Okay? The reason we do that is because remember up here, x, these were all the term, right? First term, second term, third term, fourth term, so on. That represents x. So that's why I'm going to plug a 10 in for x. 3 times 10 is 30. 30 minus 1 is 29. Right? Again, not too hard to just continue the table. You can do that. It's totally fine. But if you have an equation, might as well use it, right? Okay. Got another example here. Describe how the numbers are changing. Okay, so again, I'm going to write this linear equation up here, y equals mx plus b. Remember, an arithmetic sequence is a linear equation. Describe how the numbers are changing. The first term is 9. If I go from 9 to 7, that's subtracting 2. 7 to 5, subtracting 2, right? It keeps on subtracting 2. So what do you think your slope is? Negative 2, right? Yeah. Let's continue that in the table. 9 minus 2 is 7. 7 minus 2, 5, 3, 1. 1 minus 2, negative 1. Cool, okay? Now let's graph it. 1, comma 9. Remember that. So 1, comma 9. I should point out this is subtracting, right? The slope we said was negative 2, right? What's a negative slope look like? Think about that. 2, comma 7. It's going down, right? 3, comma 5. 4, comma 3. 5, comma 1. And then 6, comma negative 1. All right, so that's kind of down there. Cool, you can see that negative slope going down. That's perfect. Those are things that just kind of be aware of. Keep an eye out for that, okay? Now it says, what's the number that comes before the first term? So again, we were subtracting 2 going this way, going from left to right. So if I go backwards, I'm going to add 2. Okay, so that y-intercept, or that 0 term, is going to be 11. Okay, so I'm going to kind of show this again. So as we go from left to right, you were subtracting 2. We were going down, right? Just kept going down. So if I go back, I'm going to go up. Here, it kind of continues on. So there, I should do it in red, because we're kind of using that in red earlier. There is my y-intercept. Okay. So write an equation for the sequence. Well, I know my slope is negative 2, x, and then plus 11, because that's my y-intercept. All right, what's the 10th term? Again, we could use that table. The 7th term, subtract 2 would be negative 3. The 8th term is negative 5. 9th is negative 7. 10th is negative 9. Okay, I'm going to write that to the side here. I know I should get negative 9. If you use a table, perfect. Or I could do negative 2 in parentheses 10 plus 11. Plug in that 10th term for x. Negative 2 times 10 is negative 20. And negative 20 plus 11, oh yeah, that's negative 9. Perfect. We just kind of match that up, right? So again, if you're looking for like the 100th term, it's obviously going to be a lot easier to use that equation. Just plug it in. Okay. I got a few more examples just to work with arithmetic sequences. Okay. Just a couple more examples, and I'll let you all get on to the practice. So here it says identify how the pattern is changing, then find the next 4 terms. Okay. So from 9 to 16. Oh gosh, that's hard to do in my head, right? Now in that pre-video, I told you could just do 16 minus 9. 7. 23 minus 16. 7, right? Oh, this is adding 7. That's what it's doing. Add 7. Add 7. 23 plus 7, 30. 30 plus 7. 37 plus 7. And then 44 plus 7. Okay. Perfect. So I know it's adding 7. Now remember that adding 7 is the slope. Okay. So when it says write an equation, I'm just going to start with this. Y equals mx plus b. I know my slope is 7. Okay. So y equals 7x. But what's my b? Oh, y-intercept. Right. That's my y-intercept. Is that 9? No, it's not 9. We have to go back. Remember that. So you're adding 7 going to the right. We're going to subtract 7 going to the left. So my y-intercept is 9 minus 7, which is 2. Okay. So you're always like going backwards to find that y-intercept. What's the 15th term? you could keep on counting, right? You could keep on going out 51 plus 7 plus 7, or let's just plug in 15 for x. Okay, 7 times 15 is 105. I can write that down. And then plus 2 is 107. So 107 is the 15th term. Okay. Let's take a look at one more, okay? So starting at 6, I notice we're going down, which means I'm subtracting 4. Okay, that one I can kind of recognize in my head. Again, you could do 2 minus 6, and you'd get negative 4. That's your subtract by 4. So minus 4. Again, you get to negative 2. Here we go with some negatives. Y'all ready? Negative 2 minus 4 is negative 6. You're going down 4. Go down 4 more, negative 10. Down 4 more, negative 14, and then negative 18. Okay? So I see the negative 4 as my slope. But what's that y-intercept? Well, if I go backwards, I'm going to add 4. Right? So my y-intercept is 10. 6 plus 4, 10. So it'd be negative 4x plus 10. Okay. What's the 15th term? Let's just plug it in. Negative 4 times 15 is negative 60. Plus 10 is negative 50. Negative 50 is the 15th term. Cool. That's all I got for arithmetic sequences. So there's practice on the back. You can give that a go, try that out. And there's actually one more video, Unit 1, Lesson 3. That's going to be geometric. That's going to go more in depth with that.